Good morning, everyone. I welcome you all for sixth semester Mechanical Engineering. I am V. Sushant Kumar, Department of Mechanical Engineering, Angli Institute of Technology and Management, Belagavi. Myself and Madhu K.N. sir will be handling heat transfer subject for sixth semester students. We will start this subject with module number 1. This module consists of two sections. First section is introductory concepts and definitions, and second section is steady state one dimensional heat conduction problems in Cartesian system. In introductory concepts and definitions, we will study about what is heat transfer and what is the difference between thermodynamics and heat transfer, and basic modes of heat transfer that govern the conduction, convection, radiation, heat transfer equations. We will also discuss different types of boundary conditions and general three-dimensional heat conduction equation and derivation in a Cartesian coordinate. Along with that, we will discuss polar and spherical coordinate systems. In the second half section, that is steady state one-dimensional heat conduction problems in Cartesian system. So we will discuss about derivation in one-dimensional heat conduction equation with heat generation and without heat generation. We will also discuss about various thermal conductivity and thermal resistance concepts, that is a series and parallel, and critical techniques of insulation in cylinder and spheres. We have derivations and problems, so both are given equal weightage in this module. In today's class, we will discuss what is thermodynamics and heat transfer relation, and the definition of heat transfer and application of heat transfer in our day-to-day life, and fundamental laws of heat transfer. By the end of this class, you should be able to understand how thermodynamics and heat transfer are related to each other, distinguish thermal energy from other forms of energy, and heat transfer from other forms of energy transfer, and understand basic mechanism of heat transfer, which are conduction, convection, and radiation. Let me start this concept with an example, our day-to-day example. So it's our common observation that a cold drink, a cold canned drink left in a room, if you keep it on a table, so it warms up over a period of time, and if there is a warm canned drink, if it is kept in a refrigerator, it cools down over a period of time. So what is happening here is there is a energy transfer between the system, that is can, and the surrounding. It's our observation that energy transfer, in particular I am speaking of heat energy, it always transfer from the high temperature medium to low temperature medium. So it's our day-to-day example observation. So reverse will never happen. Okay. So with this example, we will proceed further to understand the concept in a better way. You will recall from the thermodynamics that energy exists in various forms. So in this text, we are primarily interested in heat energy. We also call it as thermal energy. So heat is a form of energy that can be transferred from one system to another system as a result of temperature difference. So if there is a temperature difference, then heat transfer takes place. The science that deals with the determination of rate of such energy transfer, we call it as heat transfer. So what is the meaning of rate? That will come to in next slide. You may have this question in mind that why we need to study this heat transfer subject. After all, we can determine the amount of heat transfer for any system undergoing any process using a thermodynamic analysis. But why we need to study this? Reason is that thermodynamics is concerned with amount of heat transfer as a system undergoes from a process from one equilibrium state to another equilibrium state. It gives no information about how long the process will take. For example, if you consider, so there is a cold water of temperature 10 degrees Celsius. So if it has to reach to the room temperature, say about 25 degrees Celsius, how much time it takes, that information is not given using the thermodynamic concepts. Of course, we will come to know the amount of heat energy that is transferred. If we know initial temperature and final temperature using the formula mCp delta T, we come to know amount of energy transferred. But how much time it takes to reach from 10 degrees Celsius to 25 degrees Celsius, that information is not given. That information we get in this subject, heat transfer subject. A thermodynamic analysis, it simply tells us how much heat must be transferred to realize a specified change of state to satisfy the conservation of energy principle. In practice, we are more concerned with rate of heat transfer. Rate of heat transfer. So what is the rate of heat transfer here? It is heat transfer per unit time. Okay. So what is the meaning of rate? When we use the word rate, it means it is per unit time. Okay. So we are more concerned with rate of heat transfer than the amount of heat transfer. Let me take up one more example to make this concept understand. If you go to any shop to buy a thermos flask, so what would you ask the shopkeeper? So you will ask shopkeeper to give you a thermos flask in which the liquid remains hot for more time. Like you ask him, if I buy this thermos flask, for how much time the liquid will remain hot. Okay, and shopkeeper may say that the tea, coffee, or any liquid remains hot for 6 hours, 10 hours, 12 hours. Okay, so he's giving you the time limit. Okay, so as a designer of thermos bottle, you are primarily interested in how long it will be before the hot fluid cools to a particular temperature. Okay, we are interested in rate of heat transfer. Okay, we are interested the heat transfer with respect to time rather than the amount of heat transfer. Okay, so that's the reason this subject is very important. Determining the rate of heat transfer to or from a system and thus the times of heating or cooling as well as variation of temperature is the subject of heat transfer. So what I mean to say is determining rate of heat transfer, okay, either from the system or to the system with respect to time, whether it is heating or cooling. Okay, and as well as variation in temperature. Okay, so that is the subject of heat transfer. Now let's look at the differences between thermodynamics and heat transfer. Thermodynamics, it deals with equilibrium states. Okay, if you just go back to your thermodynamics subject and recall, we always, when a system changes from one state to other state, we assume that it is always in equilibrium state. But whereas heat transfer, it deals with systems that lack the thermal equilibrium. Thus, it is a non-equilibrium phenomenon. Okay, therefore, the study of heat transfer cannot be based on the principles of thermodynamics alone. Okay, we need to add other principles to this to understand the concept of heat transfer. But however, the laws of thermodynamics lay the framework for the science of heat transfer. That is important. Thermodynamics will is a basis for the study of heat transfer subject. So what the first law requires? First law requires that rate of energy transfer into a system be equal to the rate of increase of energy of that system. So that's what the first law requires. So what the second law requires, that heat be transferred in the direction of decreasing temperature. Okay, second law requires that heat be transferred. And second law gives us information of direction of heat transfer. Okay, so it is if you compare with our day-to-day example, it is like a car parked in an inclined road. Okay, when you release the brake, the car will go downwards. It will not move upwards when it is in neutral. If you consider, it is analogous to electric current. Okay, electric current flowing in a direction of decreasing voltage. Always the electric current flows in the direction of decreasing voltage. Or if you take fluid flowing, okay, always fluid flows in a direction of decreasing total pressure. Okay, the basic requirement for heat transfer is presence of temperature. Before beginning of this class, in the initial stage, I told you the heat transfer takes place always from high temperature medium to low temperature medium. Okay, so the basic requirement for heat transfer is the presence of temperature difference. There can be no heat transfer between two bodies that are at the same temperature. If the two bodies, or if the two systems, okay, are at same temperature, then there is no heat transfer taking place. The temperature difference is the driving force for heat flow, just as the voltage difference is the driving force for the electric current flow, and the pressure difference is the driving force for fluid flow. The rate of heat transfer in a certain direction depends on magnitude of the temperature gradient. What do you mean by temperature gradient here? The temperature difference per unit length. Okay, the temperature difference per unit length, or the rate of change of temperature. Okay, the rate of heat transfer in a certain direction depends on magnitude of the temperature gradient in that direction. Okay, you will understand these wordings in detail again when we go to the further concepts. Larger the temperature gradient, higher the rate of heat transfer. Okay, larger the temperature gradient, higher the rate of heat transfer. So now let us look at the application of heat transfer in our day-to-day life. So let's not go everywhere. Our body is the best example for heat transfer. Okay, so whatever food we take, that is converted into energy, and that energy is stored in the muscles, and excess energy is released to the surroundings. Okay, so we control our body temperature depending on the surrounding conditions by wearing different types of clothes. Okay, so our body is best example for heat transfer. Apart from this, the air conditioners that we use, refrigerators, and room heaters, in cold countries they use heaters, and the electronic circuits, power plants. So all these are the best example for the application of heat transfer. Apart from this, there are many other applications. Okay, I just want to name few which are familiar to us. As I told you earlier, so just the thermodynamics laws is not sufficient to understand the heat transfer subject. Along with that, we need other equations also. Okay, so the fundamental laws of heat transfer, to understand that, we need to know first law of thermodynamics, that gives us information, conservation of energy principle. It's also called as conservation of energy principle. Next, second law of thermodynamics, which tells us the direction of heat flow. Then a continuity equation, that is conservation of mass, and rate of uh, equation governing three modes of heat transfer, that is conduction, convection, radiation, that we are going to study in this subject. And empirical relation of fluid properties such as specific heat, thermal conductivity, viscosity, etc. And equation of flow, that is Newton's second law of motion, Navier-Stokes equation. Okay, very important. And the equation state of the fluid. So all these are very important fundamental laws that we need to understand in order to understand this subject. With this prior information, let's go to the main topic here, heat transfer mechanism. So heat can be transferred in three different forms: conduction, convection, and radiation. So all the modes of heat transfer require existence of temperature difference. All the three modes, conduction, convection, radiation, all the three modes require the existence of temperature difference. And one more important point is, all the modes of heat transfer are from the high temperature medium to low temperature one. Okay, so in this module, we are going to study what is conduction, convection, radiation. I'll just give you the basic information, and in upcoming modules, we will study in detail each and every mode of heat transfer in detail. Thank you for watching the video.